Moving on to three-dimensional arrays. So I guess we're just going up in dimensions. Okay, so we just did dimensional arrays. Now we're going to work on three-dimensional arrays. Not that you're going to use that as much in the sense that most of the time you're going to deal with 2D matrices, right? So basically when you just like an Excel spreadsheet, okay, so I keep going back to spreadsheet, right? So basically most of the stuff you're going to work on is going to be in a XY rows column format, okay. But going back to this 3D arrays, so you're going to pass on a list of lists, okay. So you see you have a list here, okay, and that's a second list. So you have one list of lists, second list of lists, and a third list of lists, okay. I know, confusing, but and then you have the final list, okay. So list of lists, okay. So you're going to have this three-dimensional array, okay. So you have basically three spreadsheets in one array, okay. So you have one, second, and third, okay. And you can, so basically this will follow an IJK construct. So I is the array you are choosing or the matrix you are choosing, J is the row, and K is the column, okay. So IJK construct, okay, and this is like split apart. You have the first array, the second array, and the third array, okay. I think this sort of intuitively makes it clear as to what we are talking about and how to sort of identify how to slice and dice this this set of matrices, okay. So for example, you know this one, what will this do, okay, what will this do? So this is the 0th matrix, this is the first matrix, this is the second matrix, okay. And you're going to, so it's an IJK construct, okay. So you want to, if you want to select the second matrix, you're going to pass 1, okay, and then you want to select every row, which is the second column, and every column, which is the third column, okay. And it's going to select that, extract the second row of the second matrix, okay, second row of the second matrix. So basically you want to select all the columns, okay. That means you have a colon for all the columns, but second row, okay. I think it's clear, right? Okay. Extract the second element of the last row in the third matrix like below. Okay, so you want to extract this number 26, okay. So let's conceptually think about this, okay. So you have array 3, okay, and you want to pick for the first slot, okay, you're going to have ARR 3 open square bracket 2, number 2, 0, 1 and 2, okay, and then you're going to select the last row, okay. So that means 0, 1, 2, okay. So 2 comma 2, and then the second column, okay, which is 0 and 1. So 2, 2, 1, 2, 2, 1, okay. It's going to give you the number 26. Shape will give you the dimensions, okay. Oh, sorry, shape will give you that it's basically a 3 matrices, okay, 3 matrices, okay, 3 2D arrays, okay, and it's a 3 by 3 array each, okay, 3 by 3 array and 3 of them, okay. 3 of them is the number of arrays, 3 is for rows, and this 3 is for columns, okay. Dimension A is going to be, it's a 3D array, okay, so 3, okay. So these are some functions you will probably use every once in a while later on, okay. So this creates a 1D array, one dimensional array of 4 zeros, okay. This one will create a 2 matrix array with two sort of matrices, 4 rows and 3 columns, okay, 4 rows and 3 columns for each, okay, and filled with all zeros, okay. A range creates a range of numbers from 0 to whatever the last number minus 1, okay, it's zero based indexing again, okay. and you can also use, you can specify as to how you want to sort of split that range. Okay, so why I think we did that range function in one of the modules before, right, with the native Python, right? So what's the difference between range and a range? Okay, here you can actually use decimals. Okay, so you can actually split this array with decimals. So for example, you're saying that I want an array from 2.2 to 7.89, okay, with 1.25 spaces apart. Okay, so it's going to go 2.2, 3.45, 4.7. So you're going to add 1.25 to each, and it's going to stop at 7.2, because if you add 1.25 to that, it goes beyond 7.89, so it's not going to take that number. Okay, so that was that. We can do operations on that array. Okay, that means you can add stuff to that, subtract stuff from that. Okay, so let's go back to that array 2. You remember this array 2, right? We did that, or we created it. Okay, we can add 5 to each element of that array. Okay, we have done that. We can multiply, we can divide, we can take each of them to the row to square them, right? So we have done everything. Okay, we can compare arrays. I think we used mask before, so you can do the same thing here. Okay, so you say array 2 gives you back that old array we've been working with. You want all the numbers which are greater than 5, so it's going to give you a set of booleans. Okay, and okay, so it's going to give you a set of booleans. Okay, so now you say, okay, what if I want to create a set of booleans which gives you all the numbers greater than 30 but less than or equal to 50? So you pass on this 2 arguments, okay, or this 2 conditions, okay, with an and in between. Okay, because you want this and that. Okay, so it's going to do that. So this is basically doing replace positions of elements in array 2, which is this array, that are greater than 30, okay, but less than or equal to 50 with a double of the existing values. Okay, you see that? So you're going to do greater than 30, find values which are greater than 30 or less than or equal to 50, okay, and double the values, okay, of those values, or once you find those numbers, okay, you want to double them. Okay, so let's do it step by step. Okay, first, you're going to find that boolean. Okay, so you have that, you're going to pass that boolean. Okay, let me do that. You're going to pass that boolean, okay, to this. Is going to give you these 2 numbers, because these are the only 2 numbers in that array which are greater than 30 and less than or equal to 50. Okay, and now you say, once you found those numbers or the position of those numbers, okay, you're going to say, I want to double this numbers. Okay, because that's what double of the existing values. Okay, so you found those numbers in that location or in that position of those numbers. I want a double of the numbers I found. Okay, and that's what you see. You get the final array. So I think it's pretty straightforward. You just have to sort of spend some time understanding it and maybe get a chance to play around with it. Okay, this Jupyter notebook you will get, of course, with you, so you will be able to play around with that. So what did we just do? I want to delete stuff which is not needed for you to work on. Okay, so you can sort of split that. Okay, and okay, let's continue. Okay, a little bit. Okay, we can also do Boolean indexing based on another array. Okay, so let's say you have another array called names. Okay, this names has an array. It's a string of it has a bunch of strings. Okay, which are names basically. So Bob, Joe, so and so. Okay, so Bob is repeated 2 times, Will 3 times, and Joe 2 times. Okay, so we can use conditions on the array names to select data in an array ARR1. So what was the ARR1? Okay, did we specify that? Okay, we didn't run that. Okay, so let's go back and run that again. Okay, yeah, so every time you load this notebook again, restart and clear output, you have to run all the cells pretty much all over again, just to make sure that the memory retains the. So this was our array. Okay, and you go back to that, okay, that's the array, and say names is Bob. Okay, so it's going to give you what? It's going to give you a set of booleans. Okay, so it's going to, wherever there is Bob is going to be true, that location or that index is going to have true, the remaining indices will have false. Okay, we didn't run that. Okay, names equals Bob. Okay, so you got true. Okay, rest of them are false. Now you can pass that boolean to the array 1, and you will get the two numbers which correspond to Bob. Okay, in that array 1. Okay, so this will come in handy more when we deal with data sets. Okay, so this is like doing in one line of code if you want to replace some values. Okay, so for example, you have an array 1. Okay, we were just dealing with that. Okay, array 1 greater than 0. Okay, you know there are some true, so it's going to give you a boolean. Okay, so what you want to have done is wherever you find values greater than 0. Okay, array 1, wherever that statement is true. Okay, you want to replace that with 1, the rest of them with 0. Okay, so if you do that, it's going to have 1 here, 1 here, 1 here, 1 here, 1 here, 1. Okay, basically except these two places, everywhere will be 1. Okay, so let's see whether that is true. Okay, so 1 0 0 1 1 1 1 1. Okay, so which is what we sort of anticipated. Okay, or we can do something crazy. Okay, by this. Okay, and we can replace that with. Okay, so look at this. Even though you're passing on an integer, okay, or a numerical value, because you are passing on a string to at least one of the conditions, the rest of that is also converted to string. Okay, so that's something you want to watch out for. Okay. So this is a more complicated use case where it's not complicated. You're just replacing wherever that array 1 is 0, more than 0. At that location of that index, you want this specific set of numbers to be replaced, or if it's less than or equal to 0, you want this set of numbers to be replaced. Okay. So wherever there is greater than 0, which was, where is that array 1? Okay, so this is greater than 0, this is less than 0. So less than 0, that means it's the second element, 0 1, 0 1. So minus 100 gets replaced. Okay, so think about it. So you will have this this notebook anyway. So, and the most important thing, okay, this is where we start using a little bit of the statistical functions which we will be using over and over again. Okay, so this of course will give you the mean of that array. Okay, so it's going to add all of these numbers in the array and divide it by the count. Okay, sum is going to just sum it up. Okay, std is going to give you standard deviation. Okay, that means the variability in the array you have. Okay, cumulative sum. Okay, so it's going to add cumulatively. So 6.8 plus 76 is the second number, negative 6.8 plus 76. Third number is minus 6.8 plus 76 plus 89. So that's cumulative sum. Okay, so it's going to continue until it reaches 252.7. Okay, and you can do across rows mean by specifying an axis. Okay, axis stands for rows. Okay, axis 0 stands for rows. Okay, oh sorry, axis 0 stands for column, axis 1 stands for row. Okay, so you have two rows. Okay, in here at least. Okay, so you two rows, you basically giving you across along the axis 0. Okay, so along the rows, I'm going to find the mean. Okay, so it's going to add these two numbers, divide by 2, which is the count of these two numbers, and it's going to give you minus 1.9, 41.5, 39, so on. So along axis 1 is going to sum all this thing up and divide by the count, which is 4, and it's going to give you 40.05 and so on. Okay. Okay, so that was a bit on NumPy. I think this pretty much ends that module on NumPy. We're going to move on to series. Okay, pandas.